Let us prove that tan alpha plus sec alpha minus 1 divided by tan alpha minus sec alpha plus 1 equal to 1 plus sin alpha by cos alpha. We want to prove this identity. For that purpose, let's write LHS equal to the left hand side equal to tan can be written as sin by cos, so sin alpha by cos alpha plus sec can be written as 1 by cos, so cos alpha minus 1 as it is, whole thing divided by tan can be written as sin alpha by cos alpha, sin alpha by cos alpha. Once again, sec can be written as 1 by cos alpha and 1 can be written as it is. Now we take the LCM, and so we have it as equal to sin alpha plus 1 minus cos alpha divided by cos alpha. We can cross multiply as well, and we can write it as cos alpha divided by sin alpha minus 1 plus cos alpha. We can cancel cos alpha out, so we are left out with sin alpha plus 1 minus cos alpha divided by sin alpha minus 1 plus cos alpha. But we don't have the exact expression, so what we do is we just multiply numerator and denominator by sin alpha minus 1 minus cos alpha. Numerator and denominator by sin alpha minus 1 minus cos alpha. Minus cos alpha. If we regard this quantity as A and this one is B, and here also this turns out to be A and B, then we have something called A plus B into A minus B. So that's equal to in the denominator we have got A squared minus B squared. So sin alpha minus 1 whole thing square minus cos square alpha. How did we obtain? We have applied the identity A squared minus B squared equal to A plus B into A minus B. Once again, A squared minus B squared equal to A plus B into A minus B. Now, we don't have single result on the numerator. We actually have. We just need to rewrite it. Sin alpha minus cos alpha plus 1. Let's rewrite the numerator. And sin alpha minus cos alpha minus 1. So you absorb this to be A, and if you read this to be B, then you have got, this is to be A, and this one to be B, and here also this is to be A, and the other one to be B. Then we have, once again, read this to be A, and this one is B, then we have A plus B, and again read this to be A, and this one to be B, then we have got A minus B. So we apply the identity A plus B into A minus B equal to A squared minus B squared. So in the numerator we have sin alpha minus cos alpha whole thing square minus 1. In the denominator we have got sin alpha minus 1 whole thing square. Then we can expand it. We have A minus B whole thing square equal to A squared sin square alpha plus B square plus 1 minus 2 sin alpha minus cos square alpha. Okay, next you can expand the numerator as well. Sin alpha minus cos alpha whole thing square can be written as sin square alpha apply the identity a minus b whole thing square is a square plus b square minus 2ab minus 1 as it is. Now, in the denominator, you have got 1 minus cos square alpha. That can be written as sin square alpha. So you have got sin square alpha as it is. 1 minus cos square alpha can be written as sin square alpha minus 2 sin alpha as it is. What we have done, we have just written 1 minus cos square alpha as sin square alpha. Once again, we have 1 minus cos square alpha, that can be written as sin square alpha. The rest of the thing on the numerator is it is sin square alpha plus sin square alpha minus 2 sin alpha. In the numerator, sin square alpha plus cos square alpha is equal to 1. So we have got 1 minus 2 sin alpha into cos alpha minus 1. Wow, we can cancel 1 and 1. How did we get 1 here? Because sin square alpha plus cos square alpha equal to 1. In the denominator, sin square alpha plus sin square alpha, we can combine those two and write it as 2 sin square alpha. 2 sin square alpha minus 2 sin alpha as it is. Now we have a pretty simple expression both on the numerator and denominator. We'll just like to take 2 sin alpha common from the denominator. If we take 2 sin alpha common from the denominator, then we have numerator as it is minus 2 sin alpha into cos alpha. If we take 2 sin alpha common from the denominator, then we are just left out with sin alpha minus 1. Let's cancel sin alpha from the numerator as well as denominator. We cancel sin alpha from numerator as well as denominator and also 2. So we have got entire expression that can be written as minus, let's multiply numerator and denominator. So cos alpha by 1 minus sin alpha. But we are not getting the exact expression that we want. So let's multiply both numerator and denominator by sin alpha. Sorry, let's multiply both numerator and denominator by 1 plus sin alpha. When you do that, we have got the expression equal to cos alpha into whole thing 1 plus sin alpha in the numerator, and the denominator we have got 1 minus sin square alpha. But 1 minus sin square alpha is cos square alpha, so cos alpha whole thing into 1 plus sin alpha divided by cos square alpha. And if we cancel cos square alpha and cos alpha, we are done. We have the required result 1 plus sin alpha by cos alpha.